Hello everyone. My name is Hiroki Tada from Fujitsu Corporation. Today I will talk about introduction to Flatcar Container Linux and its applicability to SDV. First, let me introduce myself. I have been working at Fujitsu Corporation since April 2021. Since joining Fujitsu, I have worked on cloud application development and design and implementation of network device drivers. Recently, I have mainly been working on research and development of Linux distribution for SDX systems such as SDV. My interests include Linux, cloud AI, HPC, and edge computing. And as a hobby, I buy the used Blade server from auction site and use them to run OSS and develop application software at my home. Also, I usually use these servers to build SoDeV and AZL. More recently, I've also been playing around with FPGAs and robots. And today, this is today's agenda. First, I will introduce our SDX platform concept. And next, I will explain Flatcar Container Linux, which is the main topic of this presentation. And finally, I will talk about possible use cases of Flatcar on SoDeV. We are exploring appropriate platform for SDX. SDX is software-defined X, and it means that functions are defined by software rather than hardware. And this includes SDV and SDN. By defining functions in software, we have several advantages. First, it becomes possible to continuously develop and update new features. This can help us respond to diverse customer requirements. Second, it becomes easier to introduce the new technologies and open source software, and such as AI. Third, application portability can be improved by using virtualization technologies such as containers and VMs. Functions can be separated from each other. This makes it easier to customize functions for each market or customer requirement. Fourth, the system can be integrated with cloud services and CI/CD platforms. This enables a continuous cycle of development, testing, and deployment. Fifth, software applications can be updated remotely by using OTA. And we are considering the platform shown in this figure for these advantages. By using cloud services, CI/CD platforms, emulators, and OTA, we aim to enable continuous development and updates. In addition, by separating each service with containers, we can improve application portability. This makes it easier to combine services and update them separately. The key point here is base Linux platform. We are investigating whether Flatcar Container Linux can be used as a base Linux. And next, I will introduce Flatcar Container Linux. Flatcar Container Linux is a Linux distribution optimized for container workloads. It includes the minimum set of packages required to run container workloads. This helps you reduce the OS image size and can also reduce the attack surface. Flatcar also has an immutable design. The user directory of Flatcar is mounted as read-only. This helps reduce the risk of tampering and prevents unauthorized changes and user directory. Also, Flatcar supports continuous updates. Flatcar community provides updates step by step through these channels. It also has an automatic update mechanism, which makes it easier to keep the system up to date. I will explain the release channels and the automatic update mechanism later. Also, Flatcar is a Gentoo-based Linux distribution. Therefore, it can be customized by using ebuild files, which are used in a Gentoo build system. Ebuild files are similar to Yocto recipes. I will briefly explain Gentoo later. Also, Flatcar was accepted as a CNCF incubating project in August 2024. Flatcar was developed by Kimball and delivered from Core OS Container Linux. Kimball was acquired by Microsoft in 2021. Development has continued after the acquisition, and Flatcar was accepted as a CNCF incubating project. And this slide briefly shows Flatcar's sponsors and case studies. Many of its sponsors, such as Microsoft and Akamai, are related to cloud platforms. Flatcar is also used by companies such as Adobe and DeepL. In these cases, it is mainly used as an OS for Kubernetes cluster, and therefore Flatcar has mainly been used as a Linux distribution for cloud environments. As I said earlier, Flatcar is a Gentoo-based Linux distribution. So here I will briefly explain the Gentoo Linux. Gentoo has two main features. The first one is Portage. Portage is a source-based package management system. Basically, package source code is downloaded locally, and the package is built and installed on the local machine. The build process is according to instructions written in ebuild files. Also, Portage has parameters called use flags. Use flags control which features on the package are enabled. For example, when installing PyTorch, if we want to enable CUDA-related features, we need to enable the corresponding user flags. In this way, Portage makes it easier to optimize packages for specific use cases. Another feature is a rolling release model. In the Gentoo community, package e-builds are continuously updated in a single branch. Therefore, users can more easily obtain relatively up-to-date versions of packages. And Flatcar has 4 release channels, alpha, beta, stable, and LTS. This is mature in the order of alpha, beta, and stable. Alpha channel is mainly for developers. New major releases start from this channel, and new features are initially tested here. After that, some releases are promoted from alpha to beta. Beta channel is used to check compatibility with user workloads. It provides releases that are close to production ready. Then some beta releases are promoted to stable. Stable channel is for production environments. It is supported until the next major releases. In addition to these channels, Flatcar also provides LTS. LTS is supported for 18 months. It is branched from stable channel every 12 months, and there is a 6 months grace period for upgrading to the next LTS version. In this way, Flatcar provides multiple release channels. Users can choose the channel depending on their use cases. For example, beta can be used in a test environment, while stable can be used in the production environment. By using LTS, long-term operation is also possible. And here I will explain the Flatcar development environment. Flatcar packages can be built from source, and the OS image can be customized. Flatcar provides a dedicated container-based build environment. This environment includes scripts for building packages and OS images. It also includes eBuild repositories. One repository contains package ebuilds forked from the official Gentoo repository. Another repository contains ebuilds modified or added by the Flatcar community. Scripts use these ebuild repositories to build packages and OS images. We can also import ebuilds from the upstream Gentoo community. This allows us to include additional packages in the Flatcar OS image. However, compatibility of additive packages needs to be carefully verified. And And Flatcar has an update manager called Nebraska. And Nebraska periodically gets new releases from the official release server. Then client tools on each instance periodically check Nebraska for updates. If a new release is available, the client tool gets update information from Nebraska. Then it applies the update. Nebraska can also create instance groups, and we can define update policies for each group. And we can also check update status and errors and progress from a dashboard. And based on the Flatcar features introduced so far, I would like to discuss the applicability to SDV. The first point is container support. In SDV, container is an important component for improving application portability. Container is also useful when we need to deploy new technologies and software quickly. As I said earlier, Flatcar Container Linux is optimized for container workloads. Therefore, it provides a container-ready environment with very little additional setup. The second point is continuous updates in SDV. Bigger functions need to be continuously improved and evolved. To achieve this, we need a platform that can continuously introduce new technologies and software. The Flatcar community provides validated updates in short cycle. At the same time, Flatcar provides an automatic update mechanism using Nebraska. This can help reduce the operational effort required to keep the platform up to date. The third point is customizability. Flatcar provides an environment for building the OS image from source, and this makes it possible to customize the OS depending on the use cases. In other words, Flatcar can be customized and optimized for specific customer requirements and use cases. And next, I will explain how we implemented Flatcar on SoDeV. After that, I will introduce possible use cases of Flatcar. And Flatcar has many use cases in cloud environments. However, in the SDV domain, common use cases are still limited. Therefore, to explore possible use cases of Flatcar in SDV, we built a prototype of Flatcar DOM-U on SoDeV. And this slide shows the build sequence of SoDeV, including Flatcar DOM-U. We integrated the Flatcar build sequence into the build shell script and in the SoDeV demo workspace repository. In this sequence, we run build packages and build image scripts. These scripts are provided by the Flatcar community. In build packages, Portage builds packages according to ebuilds and generates binary packages. In build image, the binary packages are used to build the root reference and user partition. Then they are used to create the disk image. Finally, we use the generated disk image and the kernel image to build the Flatcar DOM-U. Now I will introduce possible use cases of Flatcar. The first use case is AI. AI is rapidly evolving area, and new models and technologies are developed continuously. By using Flatcar's continuous update model and container-based architecture, it may become easier to adapt these new technologies. For this reason, Flatcar could be a candidate as a platform for running AI applications. For example, we are considering AI applications that analyze big data from cameras, sensors, and other sources. The second use case is microservices. When multiple containers and services are used, an orchestrator is important component. With an orchestrator, we can manage deployment, zero downtime updates, and resource uses for container applications. Flatcar provides extensions for orchestrators such as K3s, and this makes it easier to install K3s on Flatcar. Next, I will talk about future work for Flatcar DOM-U. Currently, we have integrated the Flatcar build system into SoDeV demo workspace and implemented prototype of Flatcar DOM-U. These pull requests are already merged to SoDeV demo workspace repository. So you can run the Flatcar on SoDeV. Based on these works, we have two main feature tasks. The first task is remote updates. We will verify whether Flatcar DOM-U can be remotely updated by using Nebraska. The second task is to further define use cases for Flatcar DOM-U. Possible use cases include big data analysis using AI and deployment and scaling of container applications using an orchestrator. Next, I will summarize today's presentation. Flatcar Container Linux is a Linux distribution optimized for container workloads. It provides 4 release channels, so users can choose the right channel depending on their use cases. Flatcar can also be built from source, and the OS image can be customized. Flatcar has a dedicated update manager called Nebraska. Nebraska can be used to manage automatic updates From the viewpoints of container support, customizability, and continuous releases, we think Flatcar could become an important component for building an SDV system. In this work, we implemented a prototype of Flatcar DOM-U running on SoDeV. Based on this implementation, we would like to continue investigating how can be used in SDV. Possible use cases for Flatcar DOM-U include AI and microservices. However, these use cases still need to be defined in future work. Finally, if you are interested in Flatcar, let's explore its potential together. And this is all for my presentation. Thank you so much for your kind attention.
Thank you for your interesting presentation. So I have one question for Flatcar distribution. So in embedded use case, it strongly requires the reproducibility, just a snapshot. For example, snapshot at before 5 months, we reproduce this binary. We want to reproduce the same binary. So is it possible to Flatcar distribution for this feature?
Your question is,
Yes, right. For Japanese, in Japanese, so このビルドシステムで例えば2ヶ月とか3ヶ月前の、ソースコードとか全部集めてきて再現することってできますか？
それは2、3ヶ月前、それは可能だとは思うんですけど、その常に新しいアップデートが入るので、2、3ヶ月前に戻すのは大変かなというふうに僕は思ってるんですけど。
So he said it's a rolling list, so it's old build as an old binary, so it's nonsense. It's his comment. Okay. Yes, okay, thank you.
Anybody else? All right, thank you.
Thank you so much.